3 minutes ago, somewhere in the Atlantic, a beam of invisible light reached out from the deck of a 100,000-ton aircraft carrier and ended a drone's flight in less than a second. No explosion. No smoke trail. No warning. Just concentrated energy focused onto a tiny point until the metal could no longer survive, and the skies suddenly went quiet. Nobody heard it. Nobody saw it. And that is exactly what makes this story so important. Because the United States Navy has now revealed that this technology is no longer just something from a science fiction movie. A laser weapon has been fired from a real American warship against airborne targets under realistic operational conditions. And what happened next could signal the beginning of a major transformation in naval warfare. For decades, the idea of mounting a powerful laser on a warship was treated as a futuristic Pentagon experiment. It appeared in research programs, budget documents, and military demonstrations, but the technology always seemed just a little too far away from becoming a practical weapon. That is changing. The Navy has now released information and footage showing the high-energy laser system operating from the flight deck of the USS George H. Bush, one of America's massive nuclear-powered aircraft carriers. This was not simply a computer simulation. It was not a laboratory experiment. The system was installed directly on the carrier's deck and used against airborne unmanned targets in a realistic testing environment. And perhaps the strangest part is when the public actually learned about it. The testing occurred months before the Navy publicly discussed it. That delay matters because advanced military systems are rarely revealed the moment they are tested. When a capability remains classified or undisclosed for months, it can mean military planners are still evaluating exactly what they want the rest of the world to know. The ship involved was the USS George H. Bush, a Nimitz-class nuclear-powered aircraft carrier. It is enormous. The carrier can operate an air wing of roughly 90 aircraft and supports a crew of thousands of sailors. This isn't an experimental platform designed solely for weapons research. It is one of the most powerful warships ever constructed. And sitting on that enormous flight deck was a very different kind of weapon. The system is known as LOCUST, a containerized, palletized high-energy laser designed to operate as a relatively self-contained module. Instead of rebuilding an entire warship around the weapon, engineers were able to install the system directly on the deck. That detail is easy to overlook, but it may be one of the most important parts of the entire story. Because it suggests that directed energy weapons could potentially be introduced into existing military infrastructure without completely redesigning every ship from the keel up. Imagine a weapon powerful enough to damage or destroy an airborne target, yet packaged in a form that can be transported, installed, tested, and potentially moved between platforms. That changes the equation. According to the Navy's account of the testing, the system demonstrated the complete engagement sequence. Detect the target. Track it. Aim the beam. Maintain the engagement. And ultimately destroy the target. The important point is not simply that a laser can burn through something. Scientists have known for decades that concentrated energy can damage materials. The real challenge is turning that principle into a practical military weapon capable of finding a moving target, tracking it accurately, maintaining the beam on the correct location, and generating enough energy to cause meaningful damage. That is the difference between a laboratory laser and a weapon system. And this is where naval warfare becomes particularly interesting. For years, American warships have relied heavily on expensive interceptor missiles to defend themselves against aircraft, cruise missiles, drones, and other threats. Those missiles are extremely capable. But they have one unavoidable limitation. There are only so many of them on board. A warship might carry a large missile inventory, but every interceptor fired is one less weapon available for the next attack. Now imagine facing a swarm of inexpensive drones. The attacker may be able to produce and launch dozens or hundreds of relatively cheap systems. The defender, meanwhile, could be forced to respond with missiles costing hundreds of thousands or even millions of dollars each. That creates a dangerous economic imbalance. And recent conflicts have demonstrated exactly how serious that problem can become. The Red Sea has provided one of the clearest examples. Since late 2023, American and Allied naval forces operating in the region have repeatedly faced drones and missiles launched by Houthi forces in Yemen. Warships have successfully intercepted many of those threats, but doing so can consume extremely expensive ammunition. And eventually, the problem becomes larger than money. It becomes a problem of magazine depth. A warship can carry only a finite number of missiles. Once those launch cells begin to empty, the ship has fewer defensive options. A laser introduces a completely different concept. Instead of carrying hundreds of individual rounds, the weapon uses electrical power. As long as the ship can generate enough electricity and manage the heat produced by the system, the weapon can potentially continue firing again and again. There is no missile magazine to empty in the traditional sense. That is the real attraction. The laser doesn't necessarily replace missiles. Instead, it could become another layer of defense, especially against targets that are relatively inexpensive, numerous, or difficult to justify engaging with a multi-million-dollar interceptor. And that could fundamentally change how commanders think about defending a ship. Instead of asking, "How many missiles do we have left?" they may increasingly ask, "How much power do we have available?" That sounds like a small change. It isn't. It represents a completely different approach to warfare. And the United States is now putting serious money behind that approach. The Navy and Army are pursuing increasingly powerful directed energy systems, including containerized high-energy laser concepts designed to scale far beyond the power levels of some of the earliest naval laser demonstrations. The difference between early experimental systems and the weapons being developed today is enormous. Earlier naval laser demonstrations operated at power levels measured in tens of kilowatts. Newer systems are being designed around significantly higher output, with future configurations potentially reaching several hundred kilowatts. And that matters because power determines what kinds of targets a laser can realistically engage. 3 minutes ago, somewhere in the Atlantic, a beam of invisible light reached out from the deck of